right, so we have two charges. Let's be really clear. We're going to be doing an electric force problem. Now, in your formula sheet, I know you can look this up, but I just want to write it again here. We have this formula for the electric force given by the following formula. And I want to be clear on the fact that K is a constant equal to 9 times 10 to the ninth. And we want the force between these charges. So this is going to be Q1 right here, and this is going to be Q2 right over here. And we're going to go ahead and get the force as 9 times 10 to the ninth, and then we're going to times that by 2 times 10 to the negative sixth, 3 times 10 to the negative sixth, all over. I can actually put all of this over 0.03 squared. That's how fractions work, by the way. So I know I wrote it differently here versus here. That K, I get a lot of questions like, oh, is K out here or is it multiplied by the other stuff? Everything here is multiplied and divided. So you could make this line as big or small as you want for that numerator line. That's actually how these fractions work. That being said, once we plug this into our calculator, I'm going to actually end up getting an answer of 60 newtons. Okay, that is in fact the correct answer. The button that I hit on my calculator is I hit that little E button to get 10 to the power of, just to kind of do that. That's how that works. Now, here we have two equal charges. This is a bonus problem for F period. It is required for G period. And let's just run through this. So we have two equal charges separated by a distance of a certain amount. And here's what we're going to say. The old force is I have a 10 Newton force equal to K, Q1, Q2 over the distance squared. So this whole mess here is equal to 10. And now we have a new force that I'm going to go ahead and solve for. That new force, F, is equal to K, Q1, and now we're going to double the second charge, and we're going to cut the distance in half. Don't forget to put that in parentheses before you square it. And now what we're going to do is we're going to multiply some things out. So I'm going to have 2K, Q1, Q2, bringing that 2 out, all over. And this, when I square it, is going to be d squared over 4. Now here's how fractions work. When I divide, it's like multiplying by the reciprocal. So just to kind of, I'm going to do a little bit of side work here. 1 over d squared over 4 actually equals 1 times 4 over d squared. That's how reciprocals work. So what that's going to give me here is I'm going to end up getting 4 times 2 times k, q1, q2 over d squared. So when I'm finally done, this works out to be equal to 8 times k, q1, q2 over d squared. But that little k, q1, q2 over d squared, that's exactly equal to 10 right here. So it actually turns out we wind up with 80 newtons worth of force. So here, this now is G period only. We've got two charges here, and we want to know where do we place a third charge, and that charge is equal to 2 times 10 to the negative sixth coulombs. And we want to know where to place this charge so that the net force is 0. So what that means is we're going to have these two charges. They're separated. I don't like how I do that. They're separated by a distance x. And then the remainder of the distance is 0.5 minus x. And what we're basically saying is the charge here puts a force, and the charge here puts a force. And for the force to totally equal 0, those two forces have to balance. So here's how I'm going to write this. I'm going to write the force, so I'll just basically set the two forces equal to each other. I'll call this 1 and I'll call this 2, and we'll just say F1 equals F2. So we're going to say that K times 4 times 10 to the negative 6th times 2 times 10 to the negative 6th, all of that over x squared is going to equal K times 1 times 10 to the negative 6th times 2 times 10 to the negative 6th, and we'll divide that by 0.5 minus x, and we'll square all of that. Now let's cancel what we can cancel. The k's cancel, 2 times the negative 6 cancels, and this 10 to the negative 6th here cancels. So we get a simplified fraction that looks like 4 over x squared equals 1 over 0.5 minus x quantity squared. Let's actually root both sides. We're going to get 2 over x equals 1 over 0.5 minus x. I'm going to cross multiply. That's going to give me 1 minus 2x equals x. And when I simplify, x is going to be equal to, 1 minus 2x equals x. When I simplify, that's going to give me x equals 0.33 meters. So that is problem number 5 on the practice test. We'll move on to problem number 6 in the next video.